it ensures that variables are conservative. Variables mean your quantity of interest is conservative. Remember that numerical solutions are approximations, a kind of approximations. So when we have physically some energy available, then it should remain conserved by applying any numerical method. So finite volume method ensures that the variables are conservative. Variables mean your quantity of interest, like density, for example, momentum, for example, so on. Velocity as well. So mass, momentum, and energy remains conserved. The second thing, it can deal with discontinuity, which was a negative point of finite difference method. It can deal with discontinuous solution. And that was actually this was the point where scientists invented or finite volume method, since it can deal with shock waves, for example. So this is one of the plus point of finite volume method. So these are some of the advantages. The quantity remain conserved. It can deal with discontinuous solution. Now we come to the disadvantages. And one of the advantages of finite volume method is it can deal with complex geometry. It can deal with complex geometries. For example, we have softwares available like ANSYS. In ANSYS, in the background, the numerical method is used, that is finite volume method. Since when we have different geometries, complex geometries, in which finite difference method is not very easy to handle, then we can apply finite volume method. And that's the reason the ANSYS people actually used finite volume method in this software. And another software, that is OpenFOAM. In OpenFOAM as well, they implemented finite volume method in the background. Now, what are the disadvantages? One of the disadvantages is finite volume method requires integration. We will talk about that in the future. Requires integration over the control volume. And we have to compute, for example, fluxes and the integration over the volume, as well as we have to compute the fluxes. For example, if we have some geometry, we compute the fluxes at the faces, and in this volume we compute the integration, we use integration. So finite volume method is based on integration technique. Sometimes it is impossible, not impossible, but very difficult to go for a higher order schemes. It is difficult. It is difficult to increase the order. To increase the order. In finite difference method, it is very easy. For example, you can use one-sided differences or maybe higher order finite difference scheme for derivatives. Then you can construct higher order numerical methods. But in this case, it is very difficult to increase the order. So that in that case, we use Vino scheme, so on. And one of the other disadvantages are in coarser grid. Coarser mean less number of grid points. In coarser grid, we have numerical diffusion. Numerical diffusion. Numerical diffusion looks like this. For example, if we have a solution, exact solution like that, if there is a diffusion which is coming from the numerical method, then probably we have something like this. Such thing where we have a gap like this, it is called diffusion. Numerical diffusion. Why we call it numerical diffusion? Since it is coming from the numerical methods. And also we have, if we have, for example, convection dominated problems, convection dominated flow, then it can introduce diffusion in those flows as well. So, but these are the disadvantages, but the advantages are more dominant than the disadvantages of finite volume method. Remember that every numerical method has advantages and disadvantages. It's up to you to decide which numerical method you can choose for your research, for solving partial differential equation or ordinary differential equation. So we will talk about that in this course. So in next video, I will solve diffusion equation with finite difference method first, then I will solve diffusion equation with finite volume method so that you can see the difference between two. Thank you for watching.